All right, hi guys. We're going to start with lesson 126. All right, so in this lesson we're going to talk about quadrilaterals and then chords and arcs. So quadrilaterals are polygons with four sides. I'm sure you all know that. So we're going to go over the different properties of different quadrilaterals. So we're going to start with a parallelogram. A parallelogram has two sides that are the same or congruent, and the other two sides are congruent. The opposite angles are going to be equal, and the other two are also going to be equal. And when we add up those two, we're going to get 180 degrees. So the diagonals are going to bisect each other, and as you can see. Now, rhombi are a special type of parallelogram where all four sides are equal. The diagonals still bisect each other, just like in the other parallelograms. And the diagonals are going to bisect the angles in the corners. Another special property of the rhombi is that the diagonals intersect at a right angle. Now, rectangles are basically just parallelograms with angles that are 90 degrees. Now, one of the special properties of rectangles is that the diagonals are equal. So if we take a look at this rectangle and we split it into two triangles, we can see that the bases AD are congruent. The angles ADC and DAB are congruent and they equal 90 degrees. And the heights DC and AB, they are also congruent because they are from the opposite sides of the rectangle. So therefore, AC and BD, the hypotenuses of these triangles and also the diagonals of the rectangle, are equal. All right, finally, there are squares. Squares are like parallelograms, rhombuses, and rectangles. So they have all four sides the same, which means that all the angles are going to be the same. The diagonals bisect the angles in the corners, making them 45 degrees, and they intersect at right angles. Now there are trapezoids, which is a quadrilateral with exactly two parallel sides. We can divide this trapezoid into two triangles that have the same height to make the two areas. We have the bases. Base 1 is going to be the top, the base of the first triangle, and base 2 is going to be the base of the bottom triangle. So to get the area of a trapezoid, we get the area of both triangles and add them together. So we can say it is a half of the base 1 times the height plus half of base 2 times the height. Or we can simplify it and just say it's 1/2 of the height times base 1 plus base 2. Now specifically, isosceles trapezoids have legs of equal length. So another property that comes with that is that the upper angles are going to be equal and the lower angles are going to be equal. And when we add those two different angles together, we're going to get 180 degrees. All right, moving on to circles. Here we see that if two chords are equidistant from the center of a circle, the lengths of the chords are equal. So here we can see those radii put in. We made 4 triangles. So these radii become the hypotenuse of all the triangles are formed, and they have those, they're equidistant from the center, so therefore these triangles are all congruent by the hypotenuse leg theorem. Therefore, the chords are equal because it is 2 of the other base. So from this, we can also say that if the chords are equal, they're equidistant from the center. All right, and now finally arcs. We can tell a lot about arcs. We'll start with the central angles. So if the central angles of the circle have equal measures, then the chords that are opposite the central angles have equal lengths. And if the arcs have equal length, then their corresponding chords will also have equal length. And conversely, if the chords have equal length, then the central angles have equal length. And if the chords have equal length, then the measures of the corresponding arcs are also equal.